Hello again, my future pre-calc students. So this is a second assignment that I feel is probably a bit too advanced for Algebra 2, although there are some Algebra 2 courses that would include it. It's solving trig equations, and actually you're going the other way. It's isolate the trig ratio and then find the angle that corresponds to that trig ratio. If you don't have a graphing calculator, you're going to have this, the chart. So that's why I made you do this in the first assignment, so that you'd have something to refer to if you don't have a graphing calculator. However, I think using the graphing calculator and using the table function to spot trig solutions, or any solutions for that matter, I've talked about this, how you can check your work using a calculator table, and wherever you see y equals 0, that's a solution. That's never going to go away, ladies and gentlemen, so you might as well just put that in your forever memory. I'll say it again. When you enter a particular equation, whether it's a linear, a quadratic, cubic for that matter, or rationals that we worked on earlier, radical equations, trig equations, whatever, and you find in the y column where it equals 0, or you use a zero finder, or you solve it by hand, and then you want to check, and so you know where to start your table. Any of those methods, it's great to check your work. So I'll show both ways, and I think knowing both ways is important. You could probably try to use an online meta calculator to do this, although I don't know if you can set it like by 15. You might be able to. I'll play around with that at the end of the video and then include it if I can get it figured out. So here's the idea. If you're flying, we'll say by hand here, you need to isolate the trig ratio. So subtract 1 on the first one. Where is the cosine equal to -1 on this table between 0 and 360? So the cosine is the second. There it is, at pi. Okay, so we're going backwards to figure out the solution. So the table is foolproof if it's a special right triangle trig ratio. If it's a special right, what if it's not? You know, I could give you cosine theta equals 0.91. Solve that. And now we need the use of the calculator. So this is good for special right triangle measures. I want to show you how on your calculator that you can do this to pick up the special right triangle solutions. Again, if they're not the special ones, you're going to have to know how to use a zero finder or how to use methodology, which I kind of want to leave alone now, I think. This will be for pre-calc. And so these 2 pages give you methodology and how you solve them, and it's a bit confusing with, all right, here's what the calculator gives you with the inverse trig. Here's where you got to look, and here's all the reference angle stuff and how to figure it out. I kind of want to save that and show you this method I have for picking up the solution. So you can look on your table for where the sine theta is -1. So go across the sine column, see where it's -1. Or how about something that always works? And so the question is, this method will always work for quadrantal cases and the special right triangle ratios. Okay, so you're going to go and set your table to start at 0 and go by a step at 15 degrees, and then you're going to make sure you're in degree mode. Degree mode, and set your table by step at 15 degrees. These will pick up any solutions that have special right triangle trig ratios or quadrant cases. Again, what if it's not one of those? You have a zero finder situation, or the methodology for solving using the inverse trig steps. That's a little more complicated. It's doable, but I just want to show you a way that I really like. I think it's valuable to pick up these. So you're just going to go. So there's your unit circle laid out as the x-axis. And now I want to count until I see, you know, where y equals 0. Or just go there. Let's do that. There it is, 270. Write it down, and then just convert it. 270 degrees. What is that in terms of radians? Multiply by pi over 180 and reduce it. This is 3 pi over 2. I think that's the quickest way to solve ones that are unit circle related. Again, there's ones that are not. I have not given you any on this assignment, but there are ones that are not. So you would solve this equal to 0. So 2 cosine theta equals the square root of 3, and then you'd have cosine of theta is the square root of 3 over 2 if you're going to use your table. Now you look across, where is cosine equals square root of 3 over 2? Pi over 6 and 11 pi over 6. That's okay to do that, although I don't think you're going to be able to use the table in a trig setting. So I would advise this knowledge of how can I solve any equation using a table. Whoops, I pressed the wrong thing there. How can I solve any equation using a graphing tool and a table? It's quite a powerful technique if you can use a little common sense to back it up with things. So here's the main equation. The important thing is it has to all be on one side. And then time to go. So you look in between, so 30 degrees, that's pi over 6, by the way. And then you're going up to, you go up to 360 and 330. So if you converted that to radians, it's 11 pi over 6. And that's all you check is between 0 and 360, because it starts repeating beyond 360 is just repetition. Now, you don't have to solve for the trig function, the trig ratio, if you're not using the table. Just go to the calculator, enter it in, and scroll down until you see it. So again, the calculator picks up only the special ones because that's what you have. I have it set to do. So sine theta is negative square root of 3 over 2. So where on your table would that be true? And this would come out as 4 pi over 3 and 5 pi over 3. How do you know when there's more than one solution? Well, it depends on, you know, what are you using? So you'll know by the 0 in the y column on this. It depends upon where that ratio is true. So at the quadrant cases, sometimes, most of the time it's one solution, sometimes it's two. So you just have to check it out. The calculator never fails you. Okay, it will never, ever, ever, ever fail you if you have it entered right. And or if you're looking at the graph, which, yeah, we haven't learned about these graphs yet, but I've got my window set. So if I'm using my zero finder, there it is, and there it is. This is 0 to 360 right here. So however you want to do it, I think knowing table-wise how to do these is so important. So I'm going to speed up a little bit. So where is the tangent equal to the square root of 3? So this is already solved for the trig ratio. This is at pi over 3 and 4 pi over 3. Again, look on the degrees, write it down just like I did up here, and convert it over. That's all you've got to do. It's not hard. You should know to multiply by pi over 180. It's not hard to do. What you're going to have to know if you're using the table format is that, or maybe the methodology, which is quite confusing, is you're going to have to, in something like this, get this into tangents, because your calculator, you can't put a cotangent in to your calculator, so you take the reciprocal of both sides. So this means tangent. You can do that. That's legal. So you would put tangent theta plus 1 in, and then look down from 0 to 360, or where is tangent, the third column, equal to negative 1 at 3 pi over 4 and at 7 pi over 4. So it doesn't matter what one you use. It's just that you're going to have to solve for a sine, cosine, or tangent trig ratio to use the table. Now let me show you something on 7, why the table even lets you down sometimes. So what you've got to do on 7 is you have to take cosine of theta equal to 0. And then you need to solve the other one. So it's kind of like solving this. If I said solve x times x minus 3 equal to 0, you take x equals 0 and x minus 3 equals 0, and then you get x equals 3. That's kind of what's going on with this. So you have to a little bit think about quadratics, I guess, in doing this. So, and whereas then is the tangent equal to the square root of 3. So here's what happens. As I do this out, that's a bad theta. As I do this out, I come up with pi over 2 and 3 pi over 2 here. You're using the table. And then here, it's pi over 3 and 4 pi over 3. But guess what? When I go and put this in the calculator, which I'm not going to do, but if you put that in left to right, you will not pick these two up. These are extraneous. And this is why, simply explaining this, because the tangent is equal to sine over cosine. So I could just say this. Where is this true? So I'm also solving this out. Well, where, you know, if you're solving cosine equal to 0, that puts a 0 in the bottom here. It's the best way to explain it. That's not going to be picked up on your calculator. So these are the only two. Whereas doing it out by hand, you know, using the table, you would pick those other two up, but they are extraneous. So the calculator table is going to tell you the truth as you count down. Just take the degrees and convert over to radians is all you need to do. So on 8 and 9 and 10, you have to take these factors equal to 0 and solve if you want to use the table. So that's where some of the work comes in. So this would be sine theta equals -1/2. And then look across your table. I would advise you to learn how to, on your calculator, set this up so that you can read from that. All you're doing is you're turning the unit circle into the x-axis. That's all you're doing when you do this. So 7 pi over 6, 11 pi over 6. And then this will be 0 or 2 pi, however you want to. It's the same thing. So all of these will work. 9 and 10 just involve, you know, a lot of work if you want to use the chart. So you've got to take these and factor like you would with a quadratic, and then set those factors equal to 0 and solve. So I'll show that work, and then you can look at your table. And if you didn't want to do that, you'd have to put this into the calculator. You need to be a little careful with entering cosine of x squared, and so I'll show that. So in factoring this, -1/2 and 1 are the 0, so that makes the factors 2x plus 1 times x minus 1. Same idea down here. X plus 1 times x minus 1. That's how you would factor those. That's the hint in these. And so now all that happens is that the x becomes cosine here and the x becomes sine there. You just replace it. So this is 2 cosine. So some of these are like quadratic in how you deal with them. So there's that one, and then this one is sine of theta plus 1 times. So you're now going to take these equal to 0, each factor equal to 0, like we did here, and look up on the table where that's true. So where is cosine of theta? So this whole thing gets equal to 0, and when you solve it, you'll get -1/2. Subtract 1 over and divide by 2. And then this one equal to 0 gives you 1. So where on the table is that true? Where on the table is that true? So final answers will be 2 pi over 3, 4 pi over 3, and 2 pi on this one, or 0, either way. And then here, pi over 2 and 3 pi over 2. I do want to show so if you put this one in, which I strongly advise learning this technique because it is powerful. Be careful with how you do cosine of x squared. You don't want to put it in like you see it. It's got to be like that. Cosine of x quantity squared. That's what that means. So if you don't do that, you're probably going to come up with some wrong stuff. And again, you're just going to go and search it out. So there are 3 places here. I just ran by 2 of them. So at 0, and then at 120, so that's your 2 pi over 3, and then and just convert. How do you convert 240 into radians? 240 times pi over 180. You reduce the 240 over 180, and that's the 4 over 3 that you see here. So that's something you can't forget. So that's how you can solve these. Again, the table this is why we did this if you don't have the calculator. I'm going to pause for a little bit, see if I can't fire up the meta calculator and show you how you can set one up to pick up the solutions. All right, so this is the meta calculator. Listen really close because this is quite glitchy, but you can use it. You just have to listen as to what I say. So you're going to tap on the graphing calculator. The first thing you're going to do is switch to degree mode. And then where it says equation 1, you're going to put the equation all on one side. So I'm going to do problem 9. So problem 9 is 2 cosine of x squared. So you want to enter that in a set of parentheses. So cosine of x gets its own set of parentheses and a set of parentheses around the x. Minus cosine of x minus 1. And so there it is. Do not graph it. It doesn't have a zoom trig key feature. So zoom trig kind of sets the axes to be the unit circle by a step of 15. Don't mess with that. Go right to the table. Now something this calculator does, it's weird. It throws a D in here. That's not how you should write this, but that means degree mode. It's weird. It shouldn't do that, but it does. And so we want to go to create table. And now when you create the table, you got to start at 0 and go by a step of 15 and then look for the solutions. The problem is we can't see beyond 300. So we've got 1 at 120, 1 at 240. That's your 2 pi over 3 or 4 pi over 3. So you do 300 to 3, start at 300. And now you can see, all right, so 360 is 0, which is the same as 0. So that's how you can use the meta calculator. You need to do those steps exactly and realize that the D is just degree mode there. It's really weird that it shows that, but it does. But you can use the meta calculator to graph and to look on a table. And that's it. So you can now work on